Welcome back again. Today we're going to talk about Windows forensics, and specifically we're going to start with the registry. So that's the subject of this video, and the first thing we're going to talk about is how the forensic process goes. So in general, in computer forensics, we have some basics to understand before we start. So the first thing is the artifacts. So what is the artifacts? We often hear the word artifacts a lot when we study computer forensic or from analysts themselves. We hear the word artifact. So what does it mean for a learner? So artifact is the things or the traces that the attacker or the user leaves on the system. For example, when you use your computer, your Windows, or doesn't matter the operating system keeps track all of the activities that you perform on the OS. This includes the opened files. So the opened files are considered an artifact. The network activity, such as, for example, what are the IP addresses you connected to, and what are the domains that these IP addresses resolve to. Additionally, the ports, all of these are considered artifacts. Now, some artifacts do matter to the context of the investigation, and some of them, they don't matter. Additionally, we have the programs. The programs run. What are the programs the attacker or the user run on the system? And most importantly, in the forensic scenario, we want what is called plus the timestamp. So everything we collect about the user activity should be correlated with the timestamp. For example, okay, we know now the list of the programs run by the user, but what is the timestamp when these programs were running? What is the time a specific program was run? The network activity, when the user last connected to a specific IP. The opened files, when was the last time the user opened a PDF document, for example. We want a timestamp for everything. So that's one of the basics or important basics in the forensic procedure. Okay, so in addition to the definition of artifact, we have what is called the live with offline analysis. So we have the live with offline analysis. What is the difference? So in live analysis, we do the forensic on the target machine. So it's live analysis. We use tools to analyze the live system, but live systems or analyzing the OS live, you are running the risks of attempt or tampering the evidence, because at the end the machine here has the artifacts. We have the artifacts. So when we attempt to run tools on the OS and to gather the artifacts, we are running the risk of tampering the evidence. So live forensic, it's usually less recommended than offline. So the process, that's why there is something called in the offline forensic, we have the first data acquisition. So that's the first thing. We acquire the data. Usually we image the system. We use imaging tools to image the system, such as, for example, FTK Imager. That's in Windows. You can use DD in Linux as well. And then we perform data analysis. Okay, so let's say we have acquired a copy of the OS, and now we are analyzing the data using different tools. What happened now to the original system that's supposed to be infected? Now the live system stays intact. We just shut it down and to preserve the evidence. So basically, after we complete the analysis, we come up with something called the evidence. So the evidence here will create a story, or will give us a story with, again, the timestamp of the events. So then we go to the court and we tell the judge, hey, this is what happened, and that's the timing of every single activity on the OS. So you create a story with evidence. The evidence is usually the artifacts that you have found. So now the last thing we want to make sure is the integrity of the evidence. So what we do here, before we use that acquisition or perform that acquisition on the live system, we take a hash of the cloned image. Okay, so there is a hash before so we take a hash before data acquisition. It's actually the hash taken on the cloned image. So let's say we have created a clone image of, let's say, os.image. We take a hash for this image before the analysis, and after we complete the analysis, again we take another hash. We just want to see if we tampered with the evidence, and then we present the evidence to the court. That's very brief introduction on computer forensics. Now let's talk about the registry. So the registry is a very important part to extract the artifacts. So you might be asking, okay, I know now the artifacts, but where do I find these artifacts? Now, here you go. The registry is I'm not gonna say it's the first place, but it's one of the places you would go to in order to gather the artifacts. Okay, so that's the subject of this video. So we're gonna start now with the registry. So when we talk about registry, we're talking about the Windows operating system. So there are the hives on the registry. So basically the registry, the structure of the registry is like this. So we have so here goes keys, and then we have another set of keys. Okay, and the key itself may expand into another set of keys, right? We call them the subkeys. Okay, and then we have on the right pane, if you remember, we have for every subkey, or even for every single key, we have values. They could be the word values, they could be anything else. So we have here values. So that is the registry. It is a database of keys, subkeys, and their corresponding values. Okay, now sometimes sometimes we call the key, the combination of keys and the subkeys, we call them a hive. Okay, now what are the most important, or what are the main keys in the Windows operating system? First thing, we have the user keys, we have the users with S here, and we have the local machine, and classes underscore root, and lastly we have current conf. Of course, here you have the prefix, the same goes here. All right, so now we want to know what can we find in every single one of these keys. So first, let's start with the user key. So all the keys and the subkeys under the user contains the root configuration of, so it is the conf of the currently logged in user. The currently logged in. Okay. Now on users, here we have information about all the users' profiles. the user's profiles. All the users logged on, or even the users who have never logged on. Okay, now the local machine. Here we have the config of the machine itself, the computer, regardless of the user. It doesn't matter which user. And then we have the root. The root contains many details about the software, the classes. It has many important subkeys. And here we have, lastly, the current config. Here we can see information about the hardware profile. Okay. So now let's talk about some of the tools used to image the registry. So we're gonna open a new page and now talk about some of the tools. So now we know that we have a target OS we want to acquire an image of. And let's say we agreed to take an image of the registry, meaning that we want to analyze the registry offline. So what are some of the tools? So the first tool that we can discuss is the FTK. Of course, we're talking about Windows Imager. So FTK Imager is a set of tools used for computer forensic. They have tools for imaging disks, the entire disk, tools for imaging the registry only, and also they have tool for examining the registry. So you can take an image of the registry with FTK Imager, and then you can use another tool from Access Data to examine the registry. Another tool is the Autopsy, and many other tools. We're going to talk about them in this video. Okay, so let's talk about what are the important keys that we want to look at if we want to extract important artifacts. For example, if you want to extract information about the last logged on users, what's the key I want to look at? We're going to talk about this. The installed apps. Additionally, the USB devices. So if I want to gather this information, what are the keys I want to look at? We're gonna talk about this in a while. All right. So as we said earlier, we start with the acquisition. Now, I mentioned Access Data FTK Imager that can be used to acquire the registry. Also, there is Cape Forensics, which is another tool to acquire the registry. We can also use Autopsy. Okay, so now we have acquired the registry. What are the keys that we can analyze in order to extract artifacts? So basically, for every depends on the artifacts you want to collect. For example, if I want to find out the computer and the OS details, I use these keys, right? So for every single artifact, there is a specific set of keys, subkeys that we can go to extract the artifacts. So it's not going to be practical just to read these out loud. We're going to have to take a practical scenario. So that's why I'm going to use a room from TryHackMe. It is Windows Forensics 1. Windows Forensics 1 contains a practical scenario in task 10 where we have an image of the registry that was taken during the acquisition phase. We're going to use analysis tools to view the registry and then answer the questions. The questions will ask about artifacts. So for every single artifact, you're going to see what is the key you want to take a look at. So basically, before we start the task, now we acquired data. Let's now scroll down. I mentioned some of the analysis tools. So we have RecShell. RecShell can be used directly from the command line in Linux. So basically, in Linux, we can use RecShell after acquire the key. And we can use RegRipper, which is another tool to which we can load the extracted Hive or the extracted keys. We load them and it can open a view similar to Registry Explorer. Another tool is Reg, which is built in Windows that can query a specific key. As you can see, in order to use these tools, we have to know what is the key we want to look at. So for example, in the Reg tool, we use the query and we use the key we want to query here. So after we execute this command, we're gonna find the values under this key. So as you can see, we have to provide the key every time. That's why it's important to have a note or to have notes about every single key and what information can be found under this key. Another tool is Access Data Registry Viewer. We mentioned this, and Eric Zimmerman's Registry Explorer. Some of these tools are commercial, some of them are free, but Eric Zimmerman's Registry Explorer, in addition to the command line tools, are open source and can be used. Okay, let's see here. So we have the task here, hand-on challenge. We're gonna split the view. And directly deep dive into the scenario. Oh, I remembered something. So if the previous tasks, task 9, 8, 7, they contain questions, but to answer these questions, it's very straightforward. You just have to take a look at the screenshot and answer the question. The screenshot here, the screenshots demonstrate the keys or the values found for every single key mentioned under the task. So it's very straightforward, guys. I'm gonna start directly with task 10. If you want to take a look at the answers or find the answers, you can find them in the write-up that will be attached to the video description. Okay, let's start now with this one. Okay, you're gonna say allow. Right, so the files or the registry is found here in the triage. In triage, we go to C, and we can see it looks like an image of the entire disk. Okay, so under every single directory, we can find the corresponding Hive that we can take a look at. And we have EZ tools. We're gonna use EZ tools to examine the registry. Double click on EZ tools and launch Registry Explorer. So Registry Explorer is a tool that will allow us to examine the registry offline, okay, in a way or in a fashion similar as if we are examining the registry using the original built-in tool in Windows, RegEdit. So open the tool, and now you want to load the Hive. So depending on the artifact you want to collect, our preference or our selection of the Hive will be affected. So now if you go to the first question, how many user created accounts are present on the system? So we're looking to find out information about the users created on the system. So to do that, we want to find the correct key. So I'm gonna just search for user. Okay, so user information can be found in the SAM, and SAM is mounted under the local machine key. But remember that we don't have a view of these keys. We have the image of the disk, so we want to find out the path. So usually the path is found. Let me search with SAM. Okay, so SAM domains account user. That's the path where we can find the key and the values that contain the user information. But where is the path of this? So it is under C, I guess. Let's see. C username. So NTUSER.DAT. No, NTUSER.DAT is different. Okay, so it's the SAM is found under the config here. So we're gonna go here, and yeah, it's still starting. So here is very important piece of information. So if you got an image of the disk, You might be asking, or you might be wondering, how do I now find these keys? All right, that's the thing. Now you want to find out the configuration file that contains these keys. So usually the configuration file of the Hive is located under system32 config. And these are the names that you might find: system, software, security, SAM, default. And for every file, you have the corresponding keys that you will be opening. So if you open SAM, you will be opening the local machine SAM. If you open the security file, you will be opening the local machine security key, and so on and so forth. So now it opened. I'm gonna go to file and load the Hive. I'm gonna select the triage. So the triage is here, C, and then we go to Windows, System32, and config. Okay, so take a look at these files. So you have the SAM log1. Now log files contains the transactions logs. The transaction logs keep tracks of all of the modifications and changes done to the registry. So if you want a full view or a comprehensive view of the registry, we want to take a look at the log files. So let's first examine the log one. So nothing. I'm gonna load the Hive again and select log 2. Okay, so it looks like we need to take a look at the original SAM Hive. So we open the SAM, and now we have, as you can see guys, it opened the keys. So now we have to go to root, find the SAM, and then we go to domains, account, and we expand the user subkey. We can see information about the users. So the question here is saying how many user created accounts are present on the system. If we expand the user's key, we can see the names. Okay, so here we have, let's see here, full name, the username here, under the column username, administrator, guest, default account. We can see that there are some users who are built into the system, built in. So this one is administrator. As you can see, if we expand the comment column, it is built-in account for administering the computer domain. The guest is another built-in account. Default account, a user account managed by the system. So all of these are accounts not user created, they are machine created. If you scroll down, we can see these users, and there is no comment here. And we have 1, 2, 3. So we have 3 users, or 3 user created accounts. What is the username of the account that has never been logged in? So again, we stay here in the same key information about the users. Who is the one that has never logged in? So you can take a look at the timestamps here. Last password changed, last incorrect password, last login time. Let's expand this, and remember we are taking a look at the user created accounts, don't mind the above accounts. So we see for every single user here, THM4 and 6 THM user, they have a timestamp that indicates the last login time, but THM user 2 doesn't have one, it's empty. So when it's empty, by default we assume that they never logged in. Alright, so now the question number 3. What is the password hint for the user THM4 and 6? Remember that when we create a user account and we assign a password, Windows allows us to create a hint. In case we forget the password, we remember the hint, and the hint allows us to remember the password. So let's see if there's a column called hint here. So hint, oh, this is home directory, not hint. Password hint, not this one. This is home directory. Password doesn't expire. Gonna have to expand these columns or to find the column. Password hint. This is the one. So what is the password hint? There is only one password hint actually, which is for the user THM4N6. The password hint is count. Okay, so now as you can see, guys, we gathered artifacts about the users, and now you know what is the key you want to take a look at it. And then we have to answer this question: when was the file change log accessed? So now you want to find information about the files accessed, which is another artifact. All right, so now let's see here where to look. So recent, investigating recent files. So that's the first key we want to take a look at. It's under the current user, software, Microsoft Windows, current version, Explorer, RecentDocs. But remember again that what we got from the system is not a complete view of the registry database. We've got the image of the disk. We want to find the corresponding path. Okay, so these information are held under the NTUSER.DAT. So the NTUSER.DAT can be found under, let's see, NTUSER.DAT. Scroll up. So NTUSER.DAT found under the username directory. So we're gonna have to go here and load another Hive, but this time we're gonna go to C, users. What is the user we want to? When was the file last accessed? I suppose it's THM4N6, and we got the NTUSER.DAT. Again, we can choose to load the log file, but usually if the Registry Explorer doesn't complain that the file is tampered or dirty, we're not going to load the log file. So we're going to assume it's going to be okay to load the NTUSER.DAT without the transaction logs. Primary and secondary sequence numbers don't match. This means there's an uncommitted data in the transaction logs. Do you want to replay transaction logs against this Hive? We're going to say yes. Okay, so we're going to select transaction logs. And we're going to save it under the desktop. Say yes. Do you want to load the dirty Hive? No. Alright, so we loaded the Hive. So now we'll be back to the RecentDocs. Root. It's under, let's look this up again. So software, Microsoft Windows, current version, software. And then we expand this to Microsoft. Windows, current version. All right. So let's see if there is Explorer. And there is Explorer subkey. Under this, we can see recent documents. RecentDocs is one of the keys we can take a look at to find information about the opened files. So here the question is, we're going to take a look if there is a file named changelog. So let's see here in the column target name, there is a file named changelog. And the question is, when was the file accessed? So let's check the column. Opened on. So opened on is empty here. If we expand the RecentDocs again and we highlight the text documents, when we highlight the extension of the file, we'll be able to see more details about the files that correspond or that have the text extension. So opened on this date. What's the complete path from where the Python installer was run? So here we want to look at executable files, but here under the RecentDocs we don't have recently opened executable files. So this means we have to find the timestamp of this file under another key. So one of the other keys is UserAssist. Let's see, UserAssist. UserAssist also contain information about recently opened files. So UserAssist can be found under the NTUSER.DAT again, but again this time we're gonna have to look under UserAssist instead of RecentDocs. So this is RecentDocs. We scroll down, we see UserAssist. Yes, this is UserAssist. And then we have the GID of the user. So we're gonna have to, as you can see, expand these one by one. See if under the account there's an indication of the username. Usually every GUID here can be found somewhere else in the registry that correspond to the exact username, but we don't have that luxury now to look it up. We're gonna have to find that manually here. Count, nothing else. Count. So you can see opened programs and files, but we don't know yet if these are for the user THM or the user in question. Okay, look at this. See users THM 4 and 6. So this means that these entries are for the user in question, which is good. Okay, so now find out the Python installer. It is here, as you can see, and it was last executed in 2021, 25/11. So this is the time. Yeah, it wasn't asking about the time, it was asking about the complete path, which is the complete path here. When was the USB device? Now here we get to see where to find information or artifacts about the USB devices. So one more time, I'm gonna search for USB. So we have multiple locations to look at. First we can start with mounted devices, or we can look at the local machine subkeys, including the control set, and we also can look at this. The one that worked in this scenario is this one. So we can locate this file. First we're gonna have to load the corresponding Hive. So this time we're gonna disregard the NTUSER.DAT from here, so we don't need NTUSER.DAT anymore. We want to open the system Hive, so we go to File, load the Hive, and one more time guys, most of the Hives that contain the important registry information can be found under the C, Windows, System32, the config. Now for the USB devices and the hardware, we can find that under the system. Let's try to load the log file. Well, first we load the regular one, and now it is telling us that there is that it is dirty Hive. We're gonna say yes. We're gonna load the log one, save it temporarily under the desktop, load it, and do you want to load the dirty Hive? No. Okay, root, and then we expand to current control set. There's only one current control set, which is 001. Gonna expand this, and then we highlight enumeration, and we want to see if there is a key named USB store, and indeed there is one. Let's expand this key, and there are subkeys that indicate we have two USB devices connected. And under these keys we have another subkeys. So let's see the question. When was the USB device with the friendly name USB last connected? Okay, so we have something here to note friendly name. So looks like we're gonna have to look up a column named friendly name. Let's start with the first one. So this subkey has these information, but we don't see a friendly name here. We see only data. Device parameters, device properties. Okay. The other one, we have this information. So now we want to find the friendly name, because here it doesn't have information about the friendly name. So usually we have to look up another key now. So we have mounted devices, control set in USB. Yeah, we have this one, software Microsoft Windows portable devices. This is another key we can examine. Let's take a look at this one. So software Microsoft. I don't know what happened to the files. Looks like they have been tampered with. But why are we doing this? Because the Windows Portable Devices key here contains information about the USB, including the friendly name. So when you find a friendly name here, okay, the friendly name is USB. So from that key, we can find the correlated disk ID. When we go back to USB store key here, we correlate the disk ID found here with the disk ID column in the USB store key. And we'll be able to match both with the intended USB device. And we'll find out that the last time was connected is here under this column. So it is the Kingston Data Traveler. Okay guys, so that was it for today's video. I hope you enjoyed the video, and definitely guys, I'm gonna see you later.